Welcome to the sailorship. Today we are going to discuss Naval Arc 2, Shipment Phase 2. Today we will discuss hail due to turn numericals, which is coming for 15 marks or sometimes 25 marks. So there is two formula for the hail due to turn. One is tan theta is equal to v square into bg divided by r into g into metacentric height gm. Now what is bg? bg is equal to kg minus kb. And what is kb? kg is equal to kb is draft by 2. Okay, gm is metacentric height, r is radius of turn, and g is 9.8 gravity, 9.81. Here what is v? V is speed of vessel, but in the question generally they give in knots, and we have to convert this knot into meter per second. Okay, so this is our first formula. So let's see. This tan theta is equal to v square into bg upon gm into r into g. So since B is at about half the draft, therefore tan theta is equal to v square into kg minus draft by 2 divided by metacentric height into r into g. We need to find out the v. So ship speed given in the question into 1852.3 divided by 60 into 60. This is converting speed to meter per second. Okay, what is and the side of turn? In normal case, if G is above B, this is vessel, so always G is here, buoyancy is here, so always G is above the B. So if G is above the B, the ship will hail away from the center of the turn. Okay, second, if G is below B, that means B is here, G is here, then the ship will hail on the same side of the turn. Okay, this is first formula if the normal vessel given, but if the question is mentioned the passenger vessel, then there is second formula. The same hail due to turn for passenger vessel. For a passenger vessel, the same tan theta is equal to gg1 upon gm is equal to healing moment divided by w into gm. Okay, so tan theta is equal to 0.02 into v square into kg minus draft by 2, that means bg into displacement divided by length into displacement into metacentric height. Therefore 0.02 into v square into kg draft by 2 L into gm, or tan theta is equal to v square into pg gm into r into g. So this is healing moment formula, and the speed is same. So we'll solve some numericals, pass MMD paper. So our first question is, a vessel turn in a circle in a radius of 100 meter at a speed of 50 knots. Kg is 6 meter, kb is 5 meter, metacentric height fluid is 0.6 meter. Find the heel to which the vessel will settle during the turn. Okay, so solution. What is given in the question? We have to write first one for the impression. So radius of turn 100 meter, speed 15 knots, kg 6 meter, kb 5 meter, gm fluid 0.6 meter. So first we have to convert the speed into meter per second. So ship speed into 1852.3 divided by 60 into 60. So therefore 15 into 1852.3 divided by 60 into 60 is equal to 7.718 meter per second. Now put the value in the formula. V square into pg divided by gm into r into g is equal to v is equal to 7.718 square into bg is kg minus kb, so 6 minus 5, since kg minus kb is equal to pg, divided by 9.81 into 0.6 into 100. So tan theta is equal to 0.101. So tan inverse is equal to 5.779. This is our answer. Okay, let's move to the next question. So a ship has km 7.2 meters, kg 6.7 meters, bm 4.2 meter. Calculate the heel produced to a port if she is turned in a circle of radius 530 meters, has a speed of 15 knots. To which side vessel will heel? So gm is equal to km minus kg. We know that this formula. So km is given in the 7.2 minus 6.7. So we get gm is equal to 0.5 meter. Bm is already given in the question, 4.2 meter. Radius of circle is 530 meters. Speed 15 knots. Now we have to convert speed in meter per second. So 15 into 1852.3 divided by 60 into 60 is equal to 7.718 meter per second. Now Bg is equal to Bm minus Gm. How? This is Km. Okay. This is Kb. This is Gm. So we can find out Bg. Okay, by this diagram. So Bm is 4.2 minus 0.5 is equal to 3.7 meter. So tan theta is equal to V square into Bg divided by Gm into R into G equal to 7.718 का square into 3.7 divided by 0.5 into 530 into 9.81 is equal to 0.0847 tan theta. So theta is equal to tan inverse 4.84 to starboard side. Why starboard side? Because B is below the G. So in that case it is opposite side. Now let's move to the next question. So our next question is MV Hinship at a draft, the forward draft 7.23, aft is 8.79, kg is 7.42, FSM 1732, turn in a circle of radius 380 meters and a speed of 13.2. Calculate the angle of heel to produce. So let's solve this numerical. Forward draft is 7.23 meter, aft draft is 8.79 meter, main draft add and divide by 2, 8.01 meter, and the trim is 1.56 meter by stern. Now for main draft we need to find out the LCF. So from the MV Hinship particulars we find out the LCF. Now correction. So LCF into total trim divided by LBP. So 17.586 into 1.56 divided by 143.16 from the MV Hinship particulars. So we get the correction is 0.769 meter. Hydrostatic draft is equal to aft draft minus correction. So aft draft is 8.79 minus 0.769 is equal to 8.02 meter. Correct. Now for this displacement from the MV Hinship particulars, in this draft we have to find out the displacement 16685.5, km is equal to 8.252, VCP is equal to kb, we find out 4.263. Okay, now FSC is equal to FSM upon displacement 1732 given in the question, and the Hinship particulars we find out the displacement. So we find out the FSC. Now V is equal to ship speed into 1852.3 divided by 60 into 60. So 13.2 into 1852.3 divided by 60 into 60, 6.792 meter per second. Radius is 380 meter given in the question. Okay, now we have to find out the BG. BG is equal to Km minus Gm minus Kb. Make the diagram. Okay, Gm how we find out? Gm is equal to Km minus Kg. So Km is 8.252. Corrected Kg is equal to 7.524. So we get 0.728. Okay, so this is Km, this is Gm, this is Bg. So you can find out the Bg. So therefore Bg is equal to 8.252 minus 0.728 minus 0.4.263. So Bg we get 3.261 meter. Now put the value in the formula. Tan theta is equal to V square into Bg divided by Gm into R into G. Therefore 6.792 into 3.261 divided by 380 into 0.728 into 9.81, we get 0.0554 tan theta. So tan inverse is equal to theta is equal to 3.173 degree. Next question. A ship has km 7 meters, kg 6.5 meter, draft 7 meter. Calculate the hill produced if she is done a circle of radius 500 meter at a speed of 12 knots. So km 7 meter, kg 6.5 meter, so gm is equal to 0.5 meter. Radius is given 500 meter, speed 12 knots. Now speed we have to convert ship speed into 1852.3 divided by 60 into 60. Therefore 12 into 1852.3 divided by 60 into 60 equal to 6.174 meter per second. Since kb is equal to 1 by 2 into draft, so kb is equal to 1 by 2 into 7 is equal to 3.5 meter. Now make the diagram, put the value, you can find out the bg. So bg is equal to km minus gm minus kb. So 7 minus 0.5 minus 3.5 equal to 7 minus 4 is equal to 3 meter. Put the value in the formula, v square into bg divided by gm into r into g. Therefore 6.174 का square into 3 का divide by 500 into 0.5 into 9.81 is equal to 0.04662. So theta is equal to 2.68 will be produced to the opposite the side of turning. Next question. This is also 25 marks question. MMD past paper, MV Hinchey Peter draft forward 5 meter. MV Hinchey Peter draft 5 meter, forward 5.8. Aft water of density 1.005. kg 7.5 meter, FSM 1300. Turn a circle of radius 400 meters to starboard side at a speed of 12 knots. Calculate the heel cost during the turn. Okay, so let's solve the same way. Forward draft 5.0 meter, aft draft 5.8 meter, main draft, so add and divide by 2, 5.4 meter, trim is 0.8 meter by stern. So for main draft 5.4 meter, we calculate the LCF 72.761 meter from the MV Hinchey particulars. Correction, the formula is LCF into total trim divided by LBP. LCF is 72.761 into 0.8 total trim divided by 143.16 is the fix from the MV Hinchey particulars. So we get the 0.407 meters. So height of static draft is equal to R draft minus correction. R draft is 5.8 minus 0.407 meter, so 5.393 meter. This is hydrostatic draft. For this draft from the engine headship particulars, we need to find out the three things: displacement, seawater 10658.5 tons, km 8.668 meter, kb is equal to vcb is equal to 2.892 meters. So three things we find out, but this displacement in seawater, and we need to find out the density 1.005. So we need to convert this density. So equivalent displacement of water is equal to 10658.5 into 1.005 divided by 1.025 divided by 10450.529. FSC is equal to FSM upon displacement. So FSC is given in the question 1300 divided by 10450.529. The water density displacement into 1.024 is FSC. Radius is given in the question is 400 meter. Kg is given 7.5 meter. FSC we calculated plus 0.124 meter. So corrected kg 7.624 meter. Now V is equal to ship speed into 1852.3 divided by 60 into 60, and so 12 into 1852.3 divided by 60 into 60 is equal to 6.174 meter per second. Bg is equal to km minus gm minus kb, 8.668 minus 1.044, 2.892. So Bg we get 4.732 meter. Now put the value in the formula. Tan theta is equal to v square into Bg upon gm into r into g. So 6.174 chi square into 4.732 divided by 1.044 into 400 into 9.81 is equal to 0.0440. So the tan inverse theta is equal to 2.52. Will be produced to the side opposite to the side of turning. Okay. A passenger ship of length 210 meter, displacement 20800 tons, draft 9.8 meters, kg 7.9 meters, km 8.8 meter, speed 24 knots. Does the ship satisfy the intact stability criteria regarding yield due to tons? So if you see this question, the passenger ship is given. So formula will change. The second type of formula we'll discuss in the early this video. So length is given 210 meters, displacement is given 20800 tons, kg is given 7.9 meters. Okay, km is given 8.8 meters, speed is given 24 knots, and draft is given 9.8 meters. So what is kb? Draft by 2 So 9.8 divided by 2, which is 4.9 meter. That is gm, km minus kg. Both values given in the question. So 0.9 meter is our gm. Now what is v? Ship speed into 1852.3 divided by 60 into 60. Put the value 24 into 1852.3 divided by 60 into 60. We'll get the v equal to 12.35 meter per second. Now healing moment, 0.02 into v square into bg into displacement divided by L. So 0.02 into 12.35 pi square into 7.9 minus 4.9 kg minus kb. bg is equal to kg minus kb into displacement. Length is 210. So healing moment, (906.42 tons. Put the value in the formula. Tan theta is equal to healing moment divided by W into gm. So 906.42 into 20800 into 0.9. So theta is equal to 2.77 degree. Now since hail due to turn is less than 10 degree, the vessel satisfy the intact stability criteria regarding hail due to turning for passenger ship, because as per passenger ship intact stability, the hail due to turn is less than 10 is required. Okay, let's move to one more question, then I will give you some homework, past MMD papers, so you can solve and you can send me your question in the comment box, so we'll verify. So next question is, a passenger ship, length 200 meter, displacement 21,000 ton, draft 10 meters, kg is 8 meters, km 8.8. At a service speed of 18 knots, does the ship satisfy the intact stability criteria regarding the hail due to turn? So we need to find out, and if the value is theta value is less than 10 degree, it will comply, otherwise it will not comply. So let's solve this numerical. What is given in the question? Length 220 meters, displacement is 21,000 tons, draft is 10 meters, so kb is draft by 2 is equal to 5 meter, km is 8.8 meter, kg is 8 meter, so gm is equal to 0.8 meter, v is equal to 18 knots, so v is equal to 18 into 1852.3 divided by 60 into 60, correct, 9.26 meter per second. Healing movement 0.02 into v square into kg minus kb, which is bg, into displacement divided by length. Put the value 0.02 into 9.26 pi square into 8 is 5 into 21,000 divided by length 220. So healing moment is equal to 491.0998. Put the value tan theta is equal to healing moment divided by W into GM divided by 491 into 0998 into 21,000 into 0.8. So theta is equal tan theta is equal to 0.0292. So tan inverse theta is equal to 1.67. It is less than 10 degree. The value is less than 10 degrees. That means we have to write the comment, since yield due to turn is less than 10 degree, the vessel satisfy the intact stability criteria regarding yield due to turning for passenger ship. So you can say this all the same way. All this is past MMD paper. The similar way you can solve, and you can write your answer in the comment box. So hope you enjoy. I hope you understood this field due to turn this numericals, which is coming for either 25 marks or 15 marks in the examinations. So still, if you have any doubt, write in comment box, and best of luck for the examinations.